I got scared that they're going all to listen to me. So luckily, they have this solved. My name is Kochetkov, and we do application. So, a disclaimer: everything I'm showing you today is a proof of concept. It's not a production version. It's our research done over the last few months that we decided to share. We have not even decided if it's going to be within the application inspector functionality. So for the next hour, we shall be talking about generating patches for vulnerable source code. As I told you, I'm not so much speaking on behalf of myself, but um, of the team. So there are many people behind my presentation, and I believe we should start by explaining how we got the idea of automatic patches. Application Inspector is a tool that we started developing 3 years ago for our in-house purposes. So first developers worked in the protection security analysis, and the first issue we faced was the false positives from other scanners. When you have 50 results from a scanner, you can handle them manually, but with 500, you feel helpless. So we decided to develop an analyzer, so source code and binary code. So dog fooding uh, was not so much to test, but to develop. So no secret, we use abstract interpretation of the source code and Java PHP interpretation and binary concurrently. So we tried to squeeze the most out of it, combining static and dynamic analysis and simple execution. So the main goal was to verify, to check the vulnerabilities. So we needed to confirm or refute the vulnerabilities. So to confirm or refute was easy. To build the attack vector, once it's there, we can try and see that vulnerability exists. And if not, then no. So later, when we realized that this tool could be of use to other people, so we went to the big red button concept. It means that any person, even a muggle, once he pushes a red button, he can scan the application and then check the results and see that indeed the exploit is in use. So considering the latest trends and discussing our products, I could not refrain from commenting that this is completely our own development. It's not based on any open source projects because the open source projects that would provide for those three languages this hybrid of static and dynamic does not exist. If you want, you can go out and check. And on the first stage of AI development, we learned to integrate with our PT application firewall. So we integrated in the following way. We found the vulnerability, we built the exploit, is a number of parameters. Speaking about the web application, where you exploit the vulnerability. So nothing stops us from building information for PT application firewall so that it would recognize this entry point. And once there is an attack with the parameters, so the application firewall will immediately return this query with an error. So it works great, especially in the organizations where you need the process of changing the source code is long and painful. So you find the vulnerability, you close it, and then you send to developers to fix it. But the downside, there's only irreparable downside. You need the application firewall. It's easy to fix. You just get the application firewall. Um, the second downside that the application firewall cannot understand the situation, cannot fix the situation from the end when the entry point to the exit point, we use a dangerous parameter, for instance, a comma that gets into the SQL. It's used in the application logic. And if application logic blocks it, it means that it somehow negatively impacts to the whole code semantics, because the application firewall cannot get inside the code and only to call the dangerous function, but he will block everything on the way. So once we want to fix it and start to generate patches for vulnerable code, so that we could apply them to the original code and get the protected application version. So in order to generate patches, first you need to understand what is a vulnerability and what is fixing it. To catch a vulnerability, you need to know three things. So first you need to know how it shouldn't be. So the formal prerequisite, the math, prerequisites of the bug in the code, so that we could say, yes, this code has a vulnerability. Then we should understand how it is really, because it's not always that you can take a code and analyze and say, yes, we have signs here, or no, we don't have signs here. So we have to know it. And once we can, we should build the attack vector and confirm the vulnerability. So take the formal signs of the injection. So we used more or less human language here rather than formulas. So we have the potentially vulnerable operation as interpretation of a text in a formal language. For instance, SQL inquiry, web server, or whatever, files operations, if XPath query, and on. And this text is a result of transformation of an argument at the entry point that came from the outside. In case of web application, is HTTP query. And the transforming function is a number of all the functions that our argument transforms on the way. And the sign sounds, as you know, at least one element which changes the structure of syntactic tree of the value of text up to PVO. So if we take away a comma and add tokens, we get the injection, and it gets into this, and it falls within the sign. So you can actually write equations and formally use them. That's what we're going to do next. So you cannot formalize all the vulnerabilities as a rule, because sometimes we don't know how it should be or it shouldn't be, and all types of injections beyond SQL and others that I listed can be formalized. Buffer overflow, at least for detecting, is quite easy or formalizable. Then and other things on the slide. So you can hardly formalize, as I told you, because it's unclear what is a vulnerability, what's wrong in the code, what makes it vulnerable. It's either we know it, but we cannot check. For instance, access errors is an example. If we have an application that controls access, it means that we can analyze a code and find signs of access distribution for different users. So we can find out as it is, but we don't know from the point of view of developer how it should have been looking I mean, the access policy. So, which data is accessible to which user, because you cannot judge by the code. Only the developers who develop the code know. So maximum what we can do here is to look at the access rights and then look if this access distribution is applicable everywhere. This is not just a vulnerability. This is probably just a slightly wrong development, and we need to know the formal access policy. So for the users and the signs, how you differentiate the users on the way. So approximately the same picture with the session manager. CSRF concurrency, and as a rule, you cannot reverse the code. So through the code, we can hardly understand the banking operation day. And moreover, the Rice theorem tells us that we cannot resolve the arbitrary logic. So probably we can still formalize some of the right-hand list, but actually the chart is quite accurate. Probably CSRF can be formalized for most cases. What do we have when we want to generate patches? How do we detect vulnerabilities? We have symbolic execution context graph. That's the only result of the application expector after analyzing the code. Then we work. Disclaimer again. I will only describe the graph and the way we work with it. How we get it, well, I need 2 hours to explain. And we have 2 hours presentation in Novosibirsk where we can tell you how we make it. But now I'll tell you what's in and how it can help us build patches. This is a Wanda graph. This is a normal flow where with some additional information, so-called context of symbol execution, contains of 2 parts. The condition of achieving, so under what condition we get to this point, and many values of all the variables and conditions of the objects that are achievable for this point. It's very difficult to understand what it means. There is a simple code, and I can just show you as an example. So you write down the parm1 HTTP query, then you check the parameter, the request, whatever. You can read it. After that, we check con2 parameter. If yes, we assign and rewrite as parm2, which we get from HTTP. And then if not, then we rewrite with a safe value. And then parm goes as an attribute. So in the very beginning, in the upper point here, we have absolutely empty symbol context. Epsilon means that any condition would do. An absolutely empty variable. After the first execution, the context gets one value. Parm dash means that it's a symbolic variable that contains all the values. Then parm will belong to the next value chain. And after that, we go to the next point, and then the context changes because we only get here if something happens. So we have the same number of values because there was no rewrite, and we are getting into this point only if this return does not execute. And uh, so for parm, the negative condition is the only value. So we shall come here with parm only if we don't go to return. And the same way we change the contexts. Look, there are two conditions. We cannot get to return. We must not get to return, but we must get here. And then the negation of the first condition to get here. So in this point, we get a very interesting picture. This point is achievable only if the return does not execute. And here, parm, we have two possible values. This under that condition or that. This is the context graph. So it's clear that for real application, it's unreal to keep all this graph. As soon as we have cycles and mass and arrays, there'll be no slides sufficient to show it. So the way we work with this graph, we build it, we optimize it, is our know-how that you will never know at the conference in September. But still, from the math point of view, at any moment this graph is going to be available. We can build any part of this graph within acceptable time and then somehow work with it. So after we execute all the code, build the graph, we can do the following. We can collect dangerous operations like this response rate and HTTP response to the web server, and we can look when this dangerous operation will be done. So, and we can take parm and look at the moment of execution and write it as a formula, which looks as follows. So if the condition applies, we shall have response right with the following value. We use the multitude of values that we get from this simple context. So here we can take out the second branch because it's not managed externally and it's safe. So the formula will become shorter, or we can send it up to get the conditions vulnerability. Once it's not true and con2 is true, and so there's another question that we still lack. So to get this injection, so what should be the value so that we get beyond the token or attribute? So here we determine the type of injection, which is quite trivial. We take the entry point where the symbol gets, that can bring to the injection, and then we start scanning all available string that goes to the dangerous function and remove by exception all possible types of tokens that could be there. So no, I will not show you any examples. So at the first iteration, we show the comma. So we either have the attribute or the text or HTML. Then here the pointer has dropped. So we get to this comma, and see the tag and see that indeed we shall be within the tag, and the only possible token here is the attribute value. As we know the injection point type, we know we have it in the base and all the vectors for this point. We add two conditions to the vulnerability because we have two vectors, this and this. And for each type, we have several dozens actually. And we give it to the SMT solver as a normal equation. And we get the value for those parameters. So it can have any value except true. And the reverse situation here, only true, there is no conflict. And parm 2, this equation can be solved. So the solver will select the first one. If we had a filter, this vector wouldn't do. Solver would arrange it and select this vector. And after the use of solver, we get the context attack vector. The value of entry point that that will give us an attack. The context vector is not HTTP query, but there's a restriction for the symbol context. We see the injection type, the attribute, and the vector variable is the one that gives us an injection. And we need to get the value to get into the dangerous operation. So for the context, we built HTTP. We know that the entry point that request params are parameters of HTTP query. As the entry point is there, we just built HTTP query that will exploit injection.
What do we lack? And effectively, so we have everything we need. We have all the makings, and all we need is just to tinker a little bit with what we have. What is the right patch? So let's give ourselves a good definition. So the criteria that we have for a patch. So minimum changes, right? That's very important. And so the smaller the better. Minimum invasive technique. Yeah. And then the patch that breaks the code. No one needs that kind of patch. So then patch certainly should fix the problem 100%. So if patch covers 99% of instances, better not to have such patch. And patch should not generate any additional issues. How do we get it? How do we generate a patch? So the attack vector can be likened to the generation of a patch. So we have to know how. So we need just to see the signs and see what kind of bad guys we are going against. And since those signs are necessary, so we analyze them. And but if we don't have all the signs, then actually the code may not be recognizable. And then the first definition, but the signs. So I'm giving it. So the red line goes under something that we can that is doable. Yeah, especially with injections. So that many values of the entry points. So you said the entry point, so immediately can fix all the dangerous values and stop them at the entry point. But it's the same thing that that firewall does, and then we can do it in a different fashion, so that it will not be doable. So you cannot change any structure of the syntax tree and of any value that can reach the value of PVO. And so just to get the, so to put it into the bloodstream, so to say, so to avoid that, to preclude that. Then usually, so in the majority of vulnerabilities, we can use three methods to fight. To combat them as typing, validation, and sanitation. So that bringing the dangerous value to something that so getting a line from an object. So validation is an entry parameter just to limit it. And to bring it, to put it into the brackets of a certain value. And sanitation is taking the dangerous parameter and render it not dangerous. What the difference? So the attack vector from patch. What the difference is? For the attack vector, we need to find only one way how to exploit a vulnerability. So because this is the proof that there is a vulnerability, and if we find one way, and so how the injection occurs. So we can just stop, show it to the user, and say remove it. So with patch, so we need to find all pathways from the entry point to PVO, and give the entire set of sets of different values of vector variables. So this is very important, and because that we need just to sanitize it somehow, to clean it up and validate it, because we need to have the entire set of different vector variables. Then but we used to cut the generation of the vector in once there is a first success, we just stopped it immediately, and so the first variable became the basic variable. So. And then we generated all possible pathways and all values. So the speed certainly went down. Tandem, so if there is a bigger problem with, so it's when you know the injection point, it's heuristics, and it does not give you 100% result. So because then, so we'll have only 2-3 tokens for an entire set of variables, and you cannot select the right one. If we want just to clean it up, so we need just to see what will be the underpinning grammar that would help us to do the cleanup. And then for many languages like HTML and other languages, we should not only identify the type of token, but its semantics as well, because the attributes are coded in one way and other things are coded in different ways, and so that's why it has nothing to do with entry point or the injection point. And the most formidable problem, it's the most important one, is that we should not so damage the application, because we don't care what's going to happen so after the injection occurs. Because if the application falls, collapses, because we could not do that. We could afford just to have the application die, and so that's why. So, for example, the overloaded buffer, etc. So we need just to make sure that the application is up and running, and that's because if it crashes, then it's too late. That's so if we have a patch, so we cannot. So we need to guarantee that if you use a patch, that the application will be operating. But in the previous case, so you can afford just to have the application crash for a while. And so we need just to identify the point of injection. It's very important. and very accurate identification, calculation of injection point. So we used a different algorithm. So we would put this certain symbol would put in the place of vulnerability. Instead of taint source. So then unique symbol. Then we'll take a modified parser, modified island language that allows for the appearance of special symbols in a random token. As the second step. So when we just break it into number of tokens, so then lexical definition process. So this symbol can be part of any a part of token which the grammar of the language allows for, and you can consider it as kind of a wild card from the viewpoint of the way parser sees it. And then, so once the parser has done its work, we got a syntax tree. So after the parser has done its job, and then now we need to see where this unique symbol got into which node. So then depending on what branch of the tree so this unique symbol got to, we can always realize the point of injection. The point of injection. So the tag name, opening bracket, attribute definition, closing bracket, attribute name, assignment sign, and then we can identify this unique symbol. So this is where our symbol got to, and so now we know the point of injection. And we have the value of the attribute, so to quoted attribute, semantic URL, and also the grammar of this value will be determined by its grammar. The second is more challenging, is keeping the semantics of the code undamaged, more difficult. So we have developed several rules. So first, the measures have several levels. I can talk more about that. So if you can typify it, you can typify it. If you cannot typify it, we sanitize it. We can sanitize, we validate it. And then we need just to consider all the terms of attainment of PVO and its values and its arguments during typifying. So it's easier to show you some examples of typifying without change of the source code. And so we have so the entry of dangerous value occurs here, and then without any change it gets here. And then we use the algorithm I described, and we identify that this is the URL semantic quoted attribute, semantic URL value, and that means that the typifying is possible. So then the patch looks like this. We typify so the parameter, and then we get the URL and the second volume of the library. And then so then when we assign the harmful value, we put this object together again, and using its safe version that will not allow to come out of the brackets of the token. The rest is unchanged and stays as was, and becomes safe. So then have the standard HTML that turns into this function. Then if we put it into sanitizing, then would have spoiled the semantics, and because tag values would be different after the sanitizing function was done. And so that's why we do it pinpoint, so where the problem is. That's where sanitize, same examples, just the injection point has changed. was changed. Sanitizing the same harmful spot. So here, so the injection spot changed. So the HTML grammar changed. So the semantic random text here. So we cannot typify it, type it. We cannot typify it, and but we can sanitize it because it should be safe from the viewpoint of HTML grammar and the text. So patch looks even simpler. So in this dangerous spot, we got PARM2 and in HTML coding. And validation. Unfortunately, we don't show it on injection points because injections the languages. So usually the first two types are sufficient to fix the problem. So we cannot do this, the lines escaping and sanitizing is always possible. And this is a very rare example, but so this is the overload of the buffer running over. And so you see the size of the buffer structure, which has indications as to the symbols. And so the way you do it, you create a new buffer. So you get the first argument of the command line, then you get the array, then you measure the size of the buffer and the length of the argument, and then so there is a mistake. There is a mistake by developer. So the sign should look the other way, and then the buffer copied so from the argument line. That's it. And so since the check does not go properly, so the buffer can overflow, and then it needs to be rebooted. So then typifying or sanitizing is not possible, but validation is possible. Validation is possible. At the index I calculation point, which is a harmful point, so we can turn index I into a validator. So the validator has a function that checks that the index is less than the buffer size. If it's equal or bigger than the buffer size, then the excess is cut off, or it comes back without any changes. So we turn off the validator index call and get the inability to operate the overflowed buffer. The overflown buffer. Then the way you cannot formalize all vulnerability, and you cannot do a patch for all of them. So the relationship is direct. If you can formalize, patches are possible. So for overflow, memory and semantics of the integers, the patches are built very simply. So very simple, like it was shown. And so for other, so there are either complications. So then there are specific cases we can build a patch, or we need to do more research, or it's impossible for the reasons mentioned above. And when do we need it? Right now. So there is a demo project. I can show you how it works. Vulnerabilities and .NET applications.
Если, может, вопросы есть сейчас, чтобы не терять времени.
Questions maybe now while we're preparing to demo that.
Так, наверное, тут надо будет паузу. Это из проекта год
This is the demo for one of the projects of files reflect SSS. And there's a query, and then the response you get without no changes. So the parameters of the net come back without any changes. That's a good example. So everything is straightforward. You check that the HTTP parameter square is 0. If it's not equal, it does equal 0, so then this parameter is not transformed into anything, and then it gets if it coincides, and then goes into another element of management, and then generates something else. And so we can check this vulnerability, open it up, so alert 0, put and identify that the vulnerability is taken care of. Now we can launch this the console version of the core of the analyzer.net, which works with this code, the protocol of how it works. Yeah. And so we build the context attack vector, then the variable is HTTP attack vector script parameter, and we got the patch. So then line 27, so we need to replace it starting from a line 27, column 7, so we need to remove this line and replace it with another one. So the city turns into encoding because the injection point is there. And this is it, and then the next, so the apply patch. So this has been done. Then after that, so the patch applies. And now we can ensure that the initial code changed, encoding was added on site. And now we can once again check that the vulnerability is gone. So now it works fine. This is it.
Спасибо. Микрофончик можно?
Такой вопрос. В Application Inspector бывает ли такое, что из-за
Does it happen
оптимизации
that
графа
optimizing graph,
какие-то уязвимости пропускаются?
so
Из-за
some
недостаточной
vulnerabilities may be
работы
looked
самого
over
ноу-хау и
because
нам.
so
Бывает ли,
your
что из-за
know-how.
этого какие-то уязвимости пропускаются?
Sometimes you can just miss some vulnerabilities. No, all the pathways that have dangerous transactions, they are not. So then the whole graph is not available at any point in time, and it's there only to the extent of the specific current task of the analysis.
У меня такой вопрос. В рамках интеграции Application Inspector
This integration application spectrum and virtual patching,
довольно классическим
I
виде.
think that
То
it's
есть
done in
это
a classical
формирование
form.
некого
It's a form
XML, который
XML,
содержит
which contains
символы, которые
certain symbols
привлекли, по мнению
that, in the opinion of
Inspector,
application
к потере
inspector,
недавней
bring
уязвимости.
about the operation of this vulnerability. So then they stop the use of such symbols for this parameter. But it's not a patch per se. You can just go around it by commenting, and the other methodology can be used. And you were saying that patch should be guaranteed and operational 100% of the times. I mean the patch that applies to code. You described it all correctly. So the integration of the application firewall, that's the way it works, and it's true. That's one of the weaknesses, that it doesn't take into consideration. So then a lot of values that may occur during different dangerous scenarios, and so then application inspector
И сразу же хотел продолжить. На
Another
самом деле,
follow-up.
вот эта проблема virtual patching
So this
в
virtual
контексте
patching
WAF,
problem
она
in
очень
WAF context
популярна.
is
То есть
very
никто
popular.
еще не умеет
Just
делать
no
хороший
one
virtual
knows how
patching
to
на
do
WAF.
virtual
И когда я узнал,
patch,
что
how to
Prism
do
Scanner
virtual patch as well.
совместно зарабатывает и сканер, и WAF, я
And so
подумал, блин,
when
может
I
им
learned
реально
that
получится сделать настоящий качественный virtual
maybe
patching.
they will do
На мой взгляд, мне кажется,
very
это
good
можно
virtual
сделать,
patching because I
интегрировав
think can be done if
сканер
you integrate
безопасности не
this
сигнатурным
security
анализом, а
scanner
может с
not by
машинным
signature
обучением,
analysis
может
but
те
by
параметры,
machine training.
которые
Maybe these parameters and
попали
virtual
под
patching
scope
will be
application
worked. So
inspector,
this would fall
можно
under
как-то
the
обучать
scope of
по-другому,
application
более
spectrum.
детально,
Maybe
что
they
ли.
can be taught
Вот что вы
differently,
думаете по
trained
этому
differently.
поводу, чтобы машинное
What's your
обучение
take on that? This
работало со сканером?
machine training should be done jointly with scanner. So then application firewall, so we spoke so much about that, so many new ideas there, so that I don't want just to tell you everything about that. So I think that we do have these plans in future. So trying just to identify in which spot we need to stop.
Спасибо, будем
Thank you.
посмотреть.
Okay, we'll watch you.
А там вот,
Спасибо за доклад.
Thank
В
you
двух
for
словах по
the
поводу
presentation
приоритетов
about the
контрмер.
priorities of
Выяснить.
countermeasures. So,
собственно, я ожидал.
priority, I expected that question.
И, да, у нас есть
Yeah.
максимум. Приоритет контрмер на самом деле очень
So
подробно.
the
Я в
priority,
2014
I
году
spoke in
быстро это
2013
рассказывал,
about that
что как разработать
at
еще
that
приложение
workshop.
высокого сумма.
So how to do that?
В общем
And
случае,
so
приоритет,
generally, the priority
напрямую зависит от
is
того,
related
что дальше
to
будет с этим кодом.
what's going to
Потому что
happen to
если
this
мы
code
делаем
in
типизацию,
future.
у нас
Because if we
получается
do
в самом
typing
начале точки кода
or typifying,
типизированная
so then the
формула,
entry
с которой
point
мы
is
дальше также
a
можем
certain
работать.
variable is
Допустим, если какой-то из
typified,
примеров, которые я
and
показывал,
if there are
работает
so many
дальше,
examples,
добавить,
and so then developer wants to
другую
add
ветку,
another
да,
branch,
другую ветку.
and so that's another entry point. Only in the mains, for the main hosts. So
Он уже сможет
then he
воспользоваться
can just
функцией
do the
переменной,
typified
которая
variable and get those little sub pieces and safely to insert them. And so that is why, so you'll have just to implement it again. Validation as one of the most pleasant thing, priority. So that's validation is good only because a good countermeasure, because it forces to stop the operation of the application and change the graph. So then so coincides or not coincides with the policy, and so or just throw out the application, or not just to follow the branch that is dangerous, but sanitizing can help you then, because this is this sanitizing may help.
Запись доступна в
Then
смотреть вебинар, который
so then you can webinar and you can just always find this on the internet. So very good presentation. So some questions, if I may. First question is a practical question. Your HTML entries done by typing. Can you do it through a router? So if you talk about the ASP.NET or response, right? It's
решение на самом деле намного глубже.
so the solution is deeper.
Считается весь веб.
So then all the web server line is symbol based. So then your opening bracket and the closing brackets much later you can do that.
Шаблонизатор,
And then templating, templator.
говорит, что нет.
So then some say no in the 70s, but in practice, in some specific cases, two options. Right? So we either have the initial form of this templator, or we have the templator for partial realization, implementation. And then you can do it partial. We take the function of the templator, phase it, phase 1000 values, and then on the basis to try to figure out its properties. And but as applied to the templator, it works only in 10% cases. Then 10% cases, so this phasing, a quasi or phasing, that might
Это,
work,
собственно, есть
but only in
сложное
10%.
выполнение, про которое вот,
10% of the
мои коллеги
times.
Сергей Грехов и Алексей Москвин год назад рассказывали.
So then my friend spoke about that a year
Следующий
ago.
вопрос, патчинг, который
Patching that
у вас делается через, я так
that you
понимаю,
do
символьное выполнение.
through a symbol
Сильным выполнением получаете
realization,
какой-то
then you
HTML-код,
get
в котором
HTML
ищете свой
code,
волшебный символ,
and
так?
there you look for this
Или это
magic
является
symbol,
физическим
right? Or you do it
выполнением?
physically. What
Про HTML-код не понял. Вот
Ну,
HTML? Yeah.
вы как, когда при патчинге, вы
When you do
ищете контекст,
patching, you look for a
в котором
context
оказывается
in
значение
which the
входной
value
переменной.
of
да,
entry
сама строка
variable.
склеивается в
Yes, so the
результате
line
потом
glued,
парсер
is glued together, and then the parser
Вот.
may
И
help.
еще вопрос по поводу вашего секретного ингредиента.
And then
Это,
this
собственно, не
this
вариация
magic
SSA формы,
ingredient, what is it?
А можно еще раз, я не расслышал.
не вариация
It's not
SSA
the
формы,
essay form. Is it a variation of essay form?
Нет,
No, work with the initial text. No,
То есть мы интерпретируем исходный
we interpret the initial text.
SSA предполагает
SSA provides for an intermediary
мы так
image. So we do it's a plenary y binary,
но оно пока еще
but it's
то есть у вас прям парсер все это делает.
so you have the parser to do that. We build IST, then interpret IST, and then we have a simulator for Java and GLM, and so we have the implementators.
и мы
And these ISTs and these interpreters, IST, they change into this graph, and then they start working with the graph.
если вопросов больше нет.
Okay, no further questions. Thank you.
До встречи. Спасибо.